right, let's start 7.6. Part 1. We're just going to get through as much as we can today.
How long are the notes?
They're long.
13 minutes.
Alright, so we'll just get through as much as we can in the next 13 minutes or so. So we're going to use everything you guys have been learning about these radicals and simplifying them and everything to start solving them. Oh, and keep in mind on our next test, since I did not put rationalizing denominators on this past test, it's going to be on the next one. Our next test, it won't be until after spring break. So don't worry about it yet, but it will be on it. Yeah, but just one assignment, so. You just get it done on that day, and then you won't have any homework. Alright. So, the principle of powers is what we're going to use to solve radical equations. So basically, we're going to start solving equations where x is inside the radical. We're going to solve for x. So we have to know how to get it out of the radical. So here's what you need to know about that. If, say, like something equals something, like a equals b, you can raise both sides to the same power, and like that's an okay thing to do. And we'll do examples so you guys see what that looks like. But this is the important thing we want to know here is that you can raise both sides of an equation to the same power, and it will like keep everything balanced. So then you could do like 16 equals 36, even though it's not true, but. Okay, let's do a simple example so you guys can see what this means. Do you guys need me to go back? Alright, let's do a simple example. Ugh, I can't see this. Alright, so here's our first equation. It's a pretty simple one. Square root of x minus 3 equals 4. Keep in mind, this minus 3 is not in the square root. So we're just solving these like normal equations. Like, you know, the first thing we did in the beginning, they were solving equations. So we want to, remember we used to put like a line through the equal sign. You don't have to do that, but you can. I think it's helpful. Yeah? No, good question. So what you want to do is you want to get just the square root or whatever kind of root it is by itself first. So how can we undo the minus 3? Add 3 on each side. So we're left over here with the square root of x. And on the other side we have 7. Now you might be able to think of the answer in your head. You're like, oh, the square root of what number is 7? So maybe you already know it, what's in there. But let's say you didn't know it. So since this is a square root, what power should we raise it to get rid of a square root? 2. So we can raise that to a 2 as long as you raise the other side to a 2. That's what that first rule said. It's okay. It's fine. Just turn it off. So a square root and a square cancel out. We're left with x equals 49. Now, here's the really important thing. When you're solving, and you should write this down. When solving by raising both sides to an even power. So when you're solving an equation, if you end up raising each side to an even power, that's when this special thing comes into play. Sometimes the answer you get could be wrong. If you raise it to an even power. So if you raised it to an even power, you must check your answer. in the original equation? Well, we did right here. We raised it to an even power, right? We raised it to a 2, which is even.
That might not work.
Because you will get one that works, probably. You might get one that works and one that doesn't work. When solving by raising both sides to an even power, you must check your answer in the original equation. So on this one, we would check 49. So we would take the square root of 49, which is 7, minus 3. What's 7 minus 3? 4. Okay, so it worked. So we're good on this one. But you just always have to check if you raise both sides to an even power. And I'll show you somewhere it ends up not working. It's kind of just because of the issue with negatives don't work in even square roots. Let's try another one. Okay, go ahead and write this one down. Square root of x and then plus 5 equals 3. Yeah, you guys can go ahead. Alright, what did you guys do to both sides first? Subtract 5. So we're left with the square root of x equals negative 2. Okay, think about it in your head right now. Is the square root of anything going to be negative 2? No. But if you were solving, you'd raise this to what power? Raise it to the second power. Those go away. So we would get x equals, what's negative 2 squared? 4. 4. But now let's check it. What's the square root of 4? 2 plus 5 is 7, right? 2 plus 5 is 7, so it didn't work. So this one has no real solution. I don't think it'll be every other problem. Yeah? Yeah, you could probably write the 0 with the slash. And then we're going to learn in a couple sections about imaginary numbers. You guys will be able to do imaginary things. Okay, let's try and get one more example done before this video ends. This is a lot bigger problem. Alright, so write down x equals the square root of x plus 7 and then plus 5. You usually do, right? But in this case, the problem is this x is trapped in a square root. So what you want to do whenever you have x's trapped in square roots, the first thing you want to do is isolate the radical that has the x trapped inside of it. That's the first thing you're going to do, is get the radical by itself, the one that has the x trapped inside. So, raise your hand if you think you know what I should do first. I want to get this radical on the side all by itself. Esther? Subtract 5 from each side. So those will go away. I'm subtracting 5 from each side. So what's left on this side? X minus 5, right? We can't put them together. We can't make them one term. They're different terms. And then on this side, we just have the root of x plus 7. So after you get the radical by itself, your second step is to raise the radical to whatever power you need. Raise radical to a power. So once you get the radical by itself, then you get to think to yourself, okay, what power do I need to raise this to get rid of the radical? So what power do I need to raise each side to? 2, because it's a square root. So I'm going to square this side, and I square this entire side. So a square root and a square cancel. So on this side, I just have the x plus 7. Now on this side, we're going to have to figure out what this is. X minus 5 squared. So x minus 5 times x minus 5. Right? Because we can't just do x squared minus 25. You can't do that. The minus ruins that. So, okay, let's go ahead and FOIL that out. X times x is x squared. And I'm going to have minus 5x minus 5x. That's minus 10x. And then negative 5 times negative 5 is plus 25. I'll give you guys a second for that to sink in. So we FOILed that. I kind of just used the shortcut because it is a perfect square trinomial. Okay, so now, like Jeff was saying, we want to get all our x's on the same side. Now the thing is, this is an x squared, and these are just regular x's. We're never going to be able to get those in the same term, right? So we know we're going to have to use something that we learned a while back, which is called the principle L-E or A-L? L-E. Principle of zero product. We learned this a while back, okay? And what it said was that if we are not sure exactly what x is, because we can't just get x by itself right now, because there's going to be an x squared and a regular x, we're going to have to factor it and set it all equal to 0. So we're going to try and get this side to be 0 now. Let's just get rid of both these things in one step. How do I move this x over here? Minus x. So we're going to subtract x from each side. How do I move this plus 7? Subtract 7. So we subtract 7 from each side. Okay, so let's see what we're left with here. We're left with x squared doesn't combine with anything. Negative 10x minus x, that's negative 11x. And then 25 minus 7 is, I think it's 18, right? And on that side is 0. But you guys can just put these right here. Thank you. You guys have to watch this video at home, sorry. Oh, nice drawings. Thank you. Okay, questions on where we are now? Okay, so I've got to factor this side. You guys have to remember factoring now. This is a nice normal factoring problem. There's nothing in front of x squared. So I'm just thinking, what multiplies to 18 and adds to negative 11? 2 and 9, what signs? Both negative, right? Negative 2 times negative 9 is 18. Negative 2 plus negative 9 is negative 11. So it's x minus 2 and x minus 9 equals 0. So I just factored it. Because we're using this principle of zero product, which says if I'm just left with a product on this side, so two things multiplied, if I'm multiplying two things together and it ends up being 0, one of those things must be 0, right? That's the only way I get 0 when I multiply things, is if one of the things is 0. So I'm going to get two answers here. It's whatever would make these things equal 0. So what minus 2 would give me 0? 2. So x equals 2. That's one answer. What minus 9 gives me 0? 9, right? So x equals 9. So I've got two answers here, 2 and 9. Only one of them is going to work.
What is 9?
Is it going to be the 2 or the 9?
9.
Let's check. We have like 1 minute. We got to check. If I don't finish this, you got to check it on your own. So let's see. My original problem was x equals the square root of x plus 7 plus 5. So let's try 2. 2 equals the square root of 2 plus 9 is, or 2 plus 7 is 9 plus 5. Let's see, is that true? Square root of 9 is 3 plus 5. That's not 2. No, 2 did not work. Let's try 9. 9 equals the square root of 9 plus 7 is 16 plus 5. Square root of 16 is 4 plus 5 is 9. That worked.
I said it was
So x equals 9 is our only answer there. Okay, we'll stop there. We'll do the rest of the notes tomorrow. You're welcome.